It is time to introduce our next speaker, and our next speaker is Soutaro Matsumoto. Soutaro is a lead Ruby engineer at Square working on static typing for Ruby. He is core Ruby committer, designed and implemented RBS for Ruby 3. He also develops Steep, a static type checker for Ruby. And the description of this talk is the Integrated Development Environment, or IDE, is one of the most frequently used tools for programming. It's a kind of text editor where you type and read the code, but it does more for you. On the fly, error reporting, completion, code to definition, and more. Soutaro has been working for IDE Development to support Ruby programming with the static type checker. It is based on the language server protocol and implemented in Ruby. All the questions, please, to stream chat, and Soutaro, it's your turn.
Okay, so here I'm Soutaro. In fact, this is my first time to attend Euruko, and I'm really very excited to have a presentation here today. I think that you may notice that my family name is same with Matt. His name is Yukihiro Matsumoto, and I'm Soutaro Matsumoto. So you may be wondering if we are some relatives or brother or like that. But in fact, it's not. We have no relation. It is because that Matsumoto is a very common family name in Japan. So let me introduce myself a bit. So I'm working for Square from Tokyo. I live in Tokyo, Japan. And I'm also one of Ruby I'm a Ruby core committers, and I have been working for the type checking things, and it was released as RBS last year. And I also developed a static type checker. It is called Steep. It is based on RBS, and it will statically type check your Ruby programs. So my talk today is not directly about the RBS or Steep, but it will be more focused on the development of IDE. But before starting my talk, I want to really quickly introduce Steep. So it is a command line to implement it in Ruby. You can install the tool using the Ruby gem or buncher, like the gem install Steep, like that. So it was originally developed as a command line tool. So it sits with a Steep command, and you can type check your Ruby project like that, the Steep check, and it will read all the Ruby source code, and it does some type checking, and it may report some type errors to the console. But as you know, this is not a very good experience. You edit some of your Ruby code in text editor, you switch to terminal, run the Steep check, and you see some errors, and then you edit your text, your Ruby source code in your editor again. So it's not very good experience. So then, I think that it's natural. So we develop an IDE plugin. It is backed by Steep. So I developed an Steep, the IDE support for Steep and VS Code extension. So you can install the VS Code extension from the marketplace, and it will help you reading and writing the Ruby code by doing the on-the-fly diagnostics reporting, or it helps the completion or it helps navigation between the Ruby code or like that. So this talk is about IDE. So what is IDE? I think that we have to think about how is the features they provide. So I think that Visual Studio is a really ancient IDE. It was it was about the 1995 or so. In fact, Visual Basic was my first programming language. I wrote some code on the Windows on the IDE and do some debugging like that. And of course, I know that the one of the most popular IDE today is VS Code. Or I have been used Eclipse for writing Android application 10 years ago. And we need to mention the really great IDE products released from JetBrains. I really love RubyMine, and it is one of my primary development environment for Ruby programs. Xcode, it is for iPhone, iOS, and maybe macOS app. And Android Studio is for Android development. You may say that Emacs is an IDE. I know we can read email or we can do everything from Emacs. And I found the funny price in the website of Beam. So this is a screenshot from the website of Beam. And I found it says, many consider it an entire IDE. So Beam itself says it's IDE. And it means that I found that it might be dangerous to discuss which one is better IDE. So it may cause some kind of better IDE. So everything is better IDE, good IDE. So there are a lot of features. They allow you to read and write text. It helps you compiling your applications or configuring something or running your tests. Or they have some debugger. It's not the bybug, but bybug itself has some kind of the command line interface. But IDE helps using the debuggers in graphical user interface. And they also have some test runners to let you write some of the unit tests with that. And some IDEs have some UI builders to put some buttons here, text areas here, like that. But then in this talk, I focus on the text editing features. So they have some syntax highlighting, forwarding, diagnostic reporting, hover, navigation, completion, refactoring. They have a lot of features on text editors. So this is a screenshot of the VS Code. And I'm trying to show you the syntax highlighting and forwarding. So you find some symbols at the left column of the editor, and we can forward and collapse some of the ranges of the Ruby code. Then, it's based on the structure of the Ruby program, and you can focus on some areas of your Ruby code. Diagnostic reporting is also important. So when you edit your Ruby code, and the IDE does some kind of the program analysis automatically in the background. And if some problems detected, it will be reported in the editor automatically. Hover is a feature to help you investigating some of the part of your Ruby code. So this is a feature of the implemented by Steve. So when your mouse pointer points some variable or method calls in the Ruby code, it shows some documentations or it shows the type of the variable. this is also implemented in Steep. And yeah, navigations. I want to explain the go-to definition features. So we click some part of the Ruby program, and if it is a method if it is a method call, it allows to jump to the definition of the method, or it jumps to the some of the definition of the types in RDS files. So completion is another one I think that you really love that. So this is also the screencast of Steep. So if you, when you are typing something, then it will show some completion candidates, and you don't have to type all of the method names or all of the variable names. So this is a screenshot from RubyMine. Some IDE supports during refactoring. It allows to renaming some methods, or it helps to defining new method by extracting some of the Ruby code. So this is a screenshot of the RubyMine because that Steep doesn't support refactoring yet. So So we see some of the IDE features, and we can find that IDE features widely depends on the knowledge of the language. So for example, I have some syntax highlighting or folding feature, but they need to know the grammar, the syntax of the programming language. Syntax highlighting for Ruby doesn't work for Java, or folding for TypeScript doesn't work well for Ruby programs. Or some more advanced features like the error reporting, navigation, refactoring, they have to be built on top of the program analysis, including type checking. So before continuing my talk, I want to quickly explain some of the levels of program analysis. So some program analysis are really complicated, but some of the program analysis are really trivial or it's easy. So one of the most trivial one is the text-based analysis icon here. So in that case, we see the input is a sequence of characters. So line equal io.getS, it means that the sequence of L and I and N and E and like that. So this analysis is not very strong. So we can do something like the line is too long, or you shouldn't. It's writing some non-ASCII characters in the code is prohibited, or like that. So we can think of a bit advanced level, the syntactic analysis icon here. So in this case, the program analyzer knows that the input is a syntax tree of Ruby programs. So line equal io.getS, they know that it is an assignment to a local variable called line, and the right-hand side of the assignment is method call, and the receiver is a local variable. But but that's it from the syntax we know. So it can be used to implement some kind of the syntax highlighting or folding, or you may know that Robocop is basically at this level. So it can produce some of the linting, the diagnostics. So in this case, we can see that there is a method call, and there is no argument, and there is some parentheses. So the Robocop may say we can develop some linters to say that we can omit the parentheses in Ruby if there is no argument given for the method call, or maybe the opposite, or like that. The most complicated one in the groups are the semantic analysis. So it is something like the type checkers or the more smart analyzers nodes. So we know that every Ruby code in the project, and we can do some reasoning much more smarter. So they may know the type of variable is that the type of the IO local variable is IO, and it has the get method and may return a string or new or exact. So some of the advanced language features like the navigations or completions, refactoring, so these features needs this level of analysis. And it is really complicated to implement the analysis. So it means that the IDE development is super difficult because the IDE products needs own program analyzers. And because that they have a different set of APIs or they are implemented in different technology, different languages, we need to make a lot of the analyzer implementations. And the bad thing is they provide essentially the same set of features. We need to develop an analyzer for Ruby Mine. We need to develop another analyzer for Visual Studio Code, for IDEs, for Beam. So yeah, it's a very bad situation. So yeah, then it's clear that what we should do next. We want to extract the analyzers. So we want to extract some language-specific IDE features, and yeah, we make some separation from the IDE front ends and the program analyzers. And we can share the program analyzer engines between the IDE front ends. And yeah, it is the protocol called RLSP. It is designed by Microsoft, and it's released 5 years ago. So this is an text from the RSP website. A language server is meant to provide to language-specific smarts and communicate with development tools over a protocol that enables inter-process communication. So it means that inter-process communication, it means that they don't have any assumption of the implementation technology of the language servers. It means that we can implement the language servers in Ruby. And yeah, so we did that. And yeah, I want to note that the LSP is supported by VS Code and a lot of text editors, including Emacs, Beam, Sublime Text. Yeah, so it's very popular technology today. So then the IDE development is really improved. So we need to implement some language-specific features based on LSP, and the IDE front end, like VS Code, Emacs, Beam, they can use the analyzer, the one analyzer, and they communicate between the communication between the IDE front end and analyzer defined on LSP. So yeah, it is that. Yeah, it is a great outcome of the LSP. There are several language servers for Ruby. Steve has a language server, and Swaggraph is a language server. And yeah, Strawberry, it is an static type checker by Stripe. They are implemented in C++, but they also support the language server. And one of the most popular VS Code extension for Ruby programming is that VS Code Ruby, and it has its own language server, and it is implemented in TypeScript. But yeah, in this talk, I focus on Steve. And yeah, I want to explain how the language server implementation will be. And then I want to share some of the tricks I found I implemented for to make the better implementation. in Ruby. So this is a diagram of the architecture of Steep. So there are some IDE front end at the left, and the Steep is at the right. So IDE front end, it means VS Code or Emacs or some editors. They invoke Steep's process, and they have some communication on pipes. It is the std.io, std input output in Steep. So the LSP message, LSP events are sent from IDE front end to Steep, and the language server component in Steep receives that, and they found some, they found something they should know, and there will be some communication between language server and type checker, and finally, the language server sends the response to IDE frontend. Let's see a bit more detail of the LSP communications. Assume you are writing in some editor and you type a new character A. Then did change text document notification will be sent from the IDE front end to Steep. It is a JSON object, and it has method and some parameters, and it contains some information that which file was changed and how the change is. And the language server component of Steep receives the events, and they know that, okay, this file is changed, so we need to update the source code in the server, and then it starts type checking. So after the type checking, Steep detects a type error. Then it will send another notification from the server to client. It's a publish diagnostics notification, and it is also a JSON object like this, and it has method and some parameters. The file is this, and there are some diagnostics at the range is this, and the message is that type IO does not have method like that. And the IDE front end receives the notification, and it will detect that, oh, there should be some kind of the error message, and it shows some indicator. In this case, that it prints it shows a red underline under the text, and yeah, you will find that, oh, there is some type error here. So this is a very quick demonstration of how the IDE front end and language server communicates. There are a lot of LSP events. Some of them about the text files are changed, or some of the events completion, definition, rename. They are to tell the language server that user is trying to complete something, or they want to go to definition, or they are trying to rename something like that. The server and client, the relationship of the server and client should be something similar to web server and web browser, but there is a difference that LSP allows sending the message from server to the IDE frontend. Publish diagnostics is that one of the examples, and there are some other events which is sent from server to client. And yeah, this is the simplified source code of the implementation of the language server. There is a main loop. It receives some events from the client, and then we see the method of the event. If it is text document did change, so it means that user types some code and the text code is changed. Then yeah, it tries to update the Ruby source code in the Steep, and yeah, detects some type errors and reports to the IDE frontend. But yeah, this is a very simplified version, but if we do something like that, there is some problem. So that it starts the type checking on every single key hit, and it will block the user's interaction. So the first you type T, JSON message will be sent, and Steve will start type checking. But then you continue typing. The next key is S, next JSON, but it's still type checking. You type A, JSON will be sent, but it's still type checking. So you type your Ruby code, but the Steve type checking is blocked. So this is a problem of responsiveness. So we want to make the language server responsive to return the response quickly to the user's interaction. But yeah, if we did the implementation naively, it will be really bad for responsiveness. So I implemented some tricks to make deep analysis more responsive. And yeah, I want to share some of the tricks today. One of the most important one is incremental type checking. So it is really simple that we type check Ruby code. It is affected by the change. It will finish much faster because that if there are 100 Ruby files in the project, but that if you change Ruby code, only one file is changed, and the 99 files are not changed at all. So we can skip type checking the 99 files, but we need to type check only one file. It will be a really big improvement. But yeah, so we say that we have the fast pass and slow pass. The fast pass is that when you change a Ruby file, so it checks only the file, and it will be fast enough. Because that type checking a Ruby file takes the 500 milliseconds to 1 second. Of course, it depends on the number of the Ruby file, but yeah, it cannot be super slow. It will be it will finish in 1 second, like that. So this is a fast pass, and the slow pass is that when you change some of the RBS files. So RBS file defines the types and interfaces of your Ruby program. It's something like the d.ts of the TypeScript, or you may think of that it's some header file in C programming. So the .c file editing is not very slow because it only compiles the source code file. But that if you change some header file, it will be many recompilation will happen. So the same thing is happening to the RBS files. So it is slow. It requires type checking all of the Ruby code, and it might take minutes, 1 minute, 2 minutes, 3 minutes, depending on the project size. So to improve that bad experience, I tried to introduce a new strategy that open files fast. So this is based on the observation of how you are writing some programs. So this is the example. The left is Ruby code. It is in the text editor, and you open that. The second one is the RBS file, and you have a lot of the files, but it's not open in your editors. So what will happen is that there are some Twitter URL method, but it says that there is no Twitter URL method. So you add some implementation, and you add the method definition to RBS file. And the type check will happen again, and the errors reported on the Twitter URL will disappear. So this is the typical use case of the IDE and text editing, and the open files first strategy will help to improve the responsiveness. It tries to type check the open files. So the open files have priority in the type checking queue, and you will find the feedback on the editing the files you are editing quickly. So yeah. I want to share the last trick I implemented, that's dropping the unrelated code. So the completion is one of the most problematic ones, because it needs more responsiveness. So the completion is a problem because users have to wait for compilation candidates when they try to use compilation. So completion you need to wait the list of the completion items, or you can just type the method names and the IDE will make no sense. So completion is the responsiveness of the completion item generation is very important. And what I did is to drop the unrelated method definition from the Ruby source code. So assume that you are trying to do some completion from the alias question method implementation. Then it means that we don't need to type information of the other method definitions, because it's clear that you are focusing on the alias question method. So yeah, it makes the type checking much faster and the completion item generation very responsive. So I have seen the first version of the Steve architecture, but this is some of the updated version. We implemented many tricks for responsiveness in the type checker implementation too. It's not only the language server implementation, but in type checker implementation. So today, there is no clear boundary between the language server component and the type checker components in the implementation of Steve. It's a bad thing, of course, from the perspective of the how can we structure the Ruby code, but responsiveness is more important. So this is the conclusion. So I have explained some IDE features need the advanced program analysis like type checking. And the new protocol, language server protocol, allows to develop the IDE to develop some of the IDE features in any language, including Ruby. And I have been working for Steve. It is a static type checker, and it's implemented in Ruby, and it supports LSP features. And I have shared some of the experience, and I found that responsiveness is that key requirement of a lot of aspects of the features. And I have shared some tricks I've made to make Steve more responsive. So that's it. So thank you. This one.
Oh, the joys of the live event. As you said, Euruko 2021 is on fire. Actually, we are not on fire, but yes, we are on fire. And also our speaker obviously were a fire. We are safe. Nothing happened. Fire department is there resolving a problem on the other side of the complex, so we are safe and we can continue here. But this truly has been a different kind of event. I'm not so sure what is gonna happen during this day, and I'm starting to be a little bit scared. But there's a lots of good jokes on Discord, and there's also a couple of pictures about what happened just. So, thank you. I wasn't able to follow your speech. I am so sorry because I had a situation on the outside, but I can see from the stream chat that there are lots of thanks and comments like this talk is fantastic. And there's also at least one question. Which language server would you recommend for VS Code users at the moment?
Okay, so yeah, I mean that my recommendation, it depends on the solutions you are trying to use. If you are using Solvit, the Solvit provides some features for IDE users. If you are trying to skip, it's a skip LSP would be a good option. And yeah, otherwise the Solargraph might be the option. And yeah, I really love using the Steep because I'm developing, I'm using Steep LSP server for the development RDS gem. And I also use the VS Code to be a built-in language server. So it is, it's difficult. I'm using Steep for type checking. And I also use the Steep VS Code language server for syntax highlighting and forwarding some of the document symbol, some of the feature. Steep doesn't provide some features, and VS Code to be provide some features.
Yeah. And we have some more comments and questions also. Somebody commented on stream chats several times, heard about LSP, but this talk make me fallen for it with the heart emoji. Thank you. And the questions, does having to make Steam interact closely with the LSP communication code also mean having to change the Steep core code in ways you would prefer not to if Steep was just a standalone type checker?
Yes, yeah. Oh, yes. So when it was a standalone command line tool, the code was a bit more simpler, but to support some of the tricks for the responsiveness, it's getting more complicated, getting more and more complicated. So yeah, it's an experience. Yes.
Yes. And one question: which language server would you did I ask this? Yes, I asked this, but I'm gonna ask: are you using a gem for implementing the LSP layer?
Oh yes, yeah. In fact, I'm using. I'm sorry, forgot the exact names, but language server to be gem also. But it's a really simple wrapper for some of the constants or some of the interfaces, and yeah, I think that it's totally up to you. You can easily implement everything on yourself.
Yeah. And let's see, there's also more comments like enlightening talk, Soutaro, thanks. Great insight into Steep and LSP, thank you. Great talk, Soutaro. Your work on gradual typing in Ruby is much appreciated. So thank you so much for coming here today and being a part of this amazing community now, and hope to see you on Discord discussions or at the stream chat. There might be new questions later for you addressed.